So we are going to start off today with a little bit of review. Our beloved trig right here, SOHCAHTOA. Does anybody actually remember what SOHCAHTOA stands for?
Sine opposite over hypotenuse.
Sine is opposite over hypotenuse. Next one is cosine. Adjacent over hypotenuse. What's our last one? Tangent. Tan is opposite over adjacent. So, a couple other things for you to remember. Angles are your capital letters. Your lowercase letters are your sides. So that's how we can tell the difference between a capital A and a little a. Capital A would be your angle. Little a would be your side. The side opposite of angle A is what we call your side A. So if we take a look at our triangle down here, up here is my angle A, so my little a would be that side down there. Here's my angle B, so my side B would be that side over there. And then my angle C, so there's my side C. So you gotta remember, big letters, angles, little letters, sides. They want us to find C, little c, to the nearest tenth. So I'm looking for that side there. Now one thing I have noticed over the years is every teacher teaches trig differently. Back when I got to teach trig before they took it out of Algebra 1, I would always tell my students to make an angle chart. We're dealing with angle 32, so I start with my angle up on top. And then H stands for hypotenuse, O stands for your opposite side, A is your adjacent side. It just helps you organize what you know. So do we know what our hypotenuse side is? No, but we have it labeled as X. That's what we're looking for. We're looking for our hypotenuse. Do we know the side opposite of angle 32? Yep. 15. Do we know our adjacent side? No, there's nothing written on our adjacent side. So then, that helps us narrow down which trig function we're going to use. Which one uses opposite and hypotenuse? Sine. So sine of 32, it's always sine with your angle measure. Opposite side, which is 15, over my hypotenuse, which is x. And then how would we go about solving this? Put that over 1, and then we can cross multiply. So 1 times 15 gives me 15. And then I have x times the sine of 32. What would I do to get x on its own? Divide by sine of 32. So let's say you do that in your calculator, and we'll see what we get for x to the nearest tenth. 29.9 is not what I got last block. 28.3 is what I had. Oh, okay. Is that coming back to us a little bit? Yeah. Alright, so we are given triangle XYZ. They told us that X is the 90-degree angle. So then my other two ones, doesn't matter which one I call Y or Z. I'm just going to label my sides, or my corners, Y, Z. So they tell us that little z is 10, so I'm going to go to the opposite side for my z. There's my 10. Little x is 22. They want us to find the measure of angle y. So again, I'm going to start with my angle y chart. Do we know our hypotenuse? Yeah, what is it? How about our side opposite of angle y? We don't know that one. How about our adjacent side? 10. So which trig function do we want to use if we have adjacent and hypotenuse? Cosine. So cosine of y equals adjacent over hypotenuse, so 10 over 22. So now this time we're looking for the angle. Last time we were looking for a side. This time we're looking for an angle. So that's when we got to do our cos to the -1. By doing that, that cancels out and you're left with just a y there. So then in your calculator, to get your cosine of the -1, you got to push the second button and then your cosine. And 10 divided by 22. So let's have you go ahead and do that. Tell me to the nearest degree. Yep. So angle y equals 63 degrees. Yeah? All right, so with our triangles now, so in geometry it was a little easier. You just drew your triangle, you figured out whatever it was you're missing. In Algebra 2, we switch it up a little bit by drawing our triangles and having them linked to the coordinate plane. So what that means is when we link them to the coordinate plane is you're going to have positive and negative values within your sine, cosine, and tangent now. So let's take a look here. So here's my y-axis. Here's my x-axis. So this is quadrant 1, 2, 3, and 4. So my triangle that I currently have drawn in there is in quadrant 1. So they gave me this point up here. That's what I started with, was the point xy. So I graphed it, and I connected it to the origin, and that gave me that line up there first. So then I created a right triangle with it, which I'm sure you're familiar with doing from geometry. So then the length of this side is your x, and the length of this side is your y. So with these triangles, first thing you always have to do is you always have to find your missing side, which we always use our Pythagorean theorem for. Your a squared plus b squared equals c squared. If you happen to be able to recognize your wonderful Pythagorean triples, you can always use those also. That makes things go a little bit faster. It's not always going to be a Pythagorean triple, though. So let's take a look at our example down here. I'm going to make this a little bit bigger so I can move it up as much as I can. So we have the point -12, -9. So if I were to graph -12, -9, what quadrant would I be in? 3. So -12, -9 would put me somewhere over there. So then again, I connect from the origin, and then I make it a right triangle by connecting to my x-axis. Since this side is along the x-axis, that's my x value of -12. On what one? There wasn't anything to figure out there. So then this side right here going down would be what? -9. So before I can do anything else, first thing I need to do is find the missing side of my triangle. So a squared plus b squared is going to equal my c squared, our Pythagorean theorem. So 12 squared gives us 144. 9 squared gives us 81. 144 plus 81, 225. But that equals our c squared. How do we get just c? Square root. So what does c equal? 15. Now this side, this diagonal side, is always going to be positive. The only negative ones will be the one along your x-axis and then in your y. Now the angle we're looking at is always that angle right up there connecting to your x-axis. Can't be this one connecting to the x-axis because that's your 90-degree angle. It's always that one right in there by the origin. Always, always, always. So now what they want us to find.
What's that symbol like right there, like that you do on the one like on the side that's going down? Oh wait, oh yeah, that's a negative 9.
Yeah, negative 9. All right, so they want us to find sine of theta. So here's my theta. Sine is what side over what side? Opposite over hypotenuse. So my opposite side would be negative 9. My hypotenuse would be 15. So now let's reduce that. What's negative 9 over 15 equal? Negative 3/5. So our sine is negative 3/5. All right, so let's do our cosine theta next. So cosine is what side over what side? Adjacent over hypotenuse. So our adjacent side would be negative 12. Our hypotenuse is 15. So what does that reduce to? Negative 4/5. And so then our tangent, opposite over adjacent. So we would have negative 9 over negative 12, which reduces to what? 3/4. And the last thing they wanted us to find was the measure of theta to the nearest tenth. So it doesn't matter which one you pick. We'll just go with sine because that's the first one here. So do second sine of negative 3/5. Let's see what we get. I'm going to warn you, it's going to be a negative. It's okay. What'd you get, Paul?
Negative 36.9.
Negative 36.9 degrees. So how do we feel about that so far? Not too bad?
Good review.
Okay. All right, let's go to the next page. All right, so we also have some reciprocal trig functions. Generally, we deal with just sine, cosine, and tangent. Now we got 3 new ones. This one is cosecant. That's what SC or CSC stands for, is cosecant. SEC is secant. And then this last one is cotangent. So we have lots of different ways we can write this. But seeing as how they are reciprocal functions, all you have to do is flip what you know. So cosecant is the reciprocal of sine. So since sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. You just flip it. If we were using the sides of that triangle on our last page, it would be the R side, which was your hypotenuse, over your Y. Secant, which is the reciprocal of cosine, would then be hypotenuse over adjacent, which would be R over X.
So under what circumstances do you do hypotenuse over opposite?
If they ask you for the cosecant. That's cosine. So that's a different function. So So then cotangent, I got to flip these. So that would be cosine over sine. Or another way we could say it is adjacent over opposite. Or your x over your y. So you just want to take them and flip them. One thing I do want to add on there, sometimes you will see them written as a different way. So just so you can get familiar with it, cosecant, they'll write it as 1 over sine. That's another way you can write your reciprocal. Secant, they sometimes write it as 1 over cosine. And then cotangent can also be written as 1 over tangent. So lots of different ways we can write them. But if you take a look at your calculator, do we have cosecant, secant, and cotangent on there? No. So generally what you'd have to do if you're going to use your calculators, turn them back into sine, cosine, or tangent, and then you can do whatever it is you need to do with it. So down here we have a picture of a triangle. We got a side of 2 and a side of 5. They want us to state the value of each of the following trig ratios. So what do we got to find first over here? We have to find our missing side. Oh my God, you're right. Yes. Find your missing side. Pythagorean theorem. Go. Well, so you should have negative square root of 21. Well, it's negative because which quadrant am I in? Quadrant 2. My x is a negative here. Because it would be 2 squared plus my missing side squared equals 5 squared. So this would give me a 4 plus x squared equals 25. And then you got to square root it. So x equals the square root of 21. But again, since I'm in quadrant 2, it's got to be negative square root of 21. All right, so let's go find these. Again, we are over here at this angle. This is my angle A. They tell you that because they say sine A, cosine A, tangent A. All of them are from angle A. So what would be our sine value of angle A, our fraction? 2/5. So now, as I was saying up above, cosecant is the reciprocal of that. So my cosecant, I just flip it, would be 5 over 2. All right, let's do our cosine next. So what would be our cosine of angle A? Negative radical 21 over 5. So then if we flip that, what's our secant? Yes. However, can we leave a radical in the denominator? No. How do we clean that up? We got to multiply top and bottom by your radical 21. We can't have a radical down there. We got to rationalize. So negative 5 times the square root of 21 would just be negative 5 radical 21. Radical 21 times radical 21 is 21. So our secant value is actually negative 5 radical 21 over 21. All right, and then our tangent of angle A. Tangent is opposite over adjacent. So 2 over negative square root of 21. Which, can I leave it that way? No. But before I rationalize it, if I flip this, we can get our cotangent nice and easy. Negative square root of 21 over 2. So now let's go back and rationalize this. Times the square root of 21 times the square root of 21. So we got negative 2 radical 21 over 21. That's our tangent value. right, so let's take a look at our second one. We have angle A is an angle in the fourth quadrant drawn to the x-axis, and cosine of A is 1/3. Determine the exact value of cosecant A. Show how you arrived at your answer. All right, so first thing I'm going to do is I'm going to draw myself a little picture. Quadrant 4. They told me the angle was in quadrant 4 drawn to the x-axis, so that means it's right up there next to the x-axis. So then they said cosine is 1/3. So we know cosine is what over what? Adjacent over hypotenuse. So my adjacent side is 1. My hypotenuse is 3. So first thing we got to do, find our missing side. So go ahead, Pythagorean theorem. Find your missing side over there. 2 radical 2. But since we're going down into the fourth quadrant, it's -2 radical 2. All right, so got our missing side. We now have to find cosecant of A. There are 2 ways we could go about this. One way is people just happen to remember cosecant of A is what over what? Hypotenuse over the opposite. So what is our hypotenuse again? 3. Our opposite side? -2 radical 2. But again, I can't leave it like that, so what do I have to do? Multiply both top and bottom by our radical 2. So 3 times radical 2 gives me 3 radical 2. -2 radical 2 times radical 2 gives us -4. And there's our exact value. So as I said, that's one way you could do it. The other way is some people go and they find the sine value and then they just flip it. So that's the other way you could do it. All right, example 3. They said if cosecant theta equals 5/4, then what is theta? So again, cosecant, not on your calculator, so we can't use it, but it's the reciprocal of which one? Sine. So sine theta would be 4/5. So now on your calculator, you can do second sine, 4 divided by 5, and then it's going to give us our theta. No.
Why don't they just say sine?
Because we're talking about cosecant. Let's go to the nearest tenth. Well, you don't need theta. You're just hitting second sine, and then 4 divided by 5. So what do we get? 53.1 degrees. So theta is 53.1 degrees. All right, our next example, example 4. Given that point P is the point -4, 1, they want us to find tangent, secant, and then the actual angle measure to the nearest degree. So I'm going to first plot the point -4, 1. And then I'm going to make my triangle out of it by connecting it to the origin and then drawing it straight down to my x-axis. So we're over there in the second quadrant. The length of the bottom of our triangle is what? -4. It's your x value from your point. The length of this one vertical piece here is 1. No, that's not a triple. Yes, it does.
Can we just use the distance formula?
It's very clearly crossing the form.
Find your missing side, Pythagorean theorem.
Well, technically, can someone use a distance?
You could. Which, if you think about it, I could stand here and give you the whole proof and prove to you that really the distance formula is a rearranged form of the Pythagorean theorem.
That's not insinuated.
Okay. So we should get square root of 17. Which actually, the square root of 17, Paul, is slightly more than 4. Just FYI.
17. I don't understand.
What's the square root of 16?
Square root of 4.
Okay, then square root of 17 is just a little higher. But you're not going straight across the boxes. You're going diagonally through them, so it takes longer. I promise. So again, our angle is always right down in the corner between your line you draw and your x-axis. So what would be our tangent of that angle? One over negative 4, so negative 1/4. Our secant value, our hypotenuse over our adjacent side, so square root of 17 over negative 4. And now they want us to find the angle measure. I would use our tangent one, because you can't do secant in your calculator. So do second tangent of negative 1/4. Let's see what we get. Where? Nope, that's square root of 17 over negative 4. Second tangent of negative 1/4. Yeah, 14 point what? Oh, nearest degree. They didn't tell me negative, is it? Was it negative? Okay. Negative 14. It means you're just going the opposite way through the quadrants. Okay. All right, so again, just a refresher over on the side there, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So we're going to be, you guys are going to get very familiar with this picture. We're going to be using this picture a lot throughout this unit. So as a little refresher, we got our quadrant 1 over here, quadrant 2, quadrant 3, and our quadrant 4.
Do we need to know what the angle is?
Yes.
Can we just go 1, 2, 3, 4?
No. So if we are in quadrant 1 and you have your triangle drawn, again, your angle is always the one down in here between your x-axis and the line that's drawn. We're always dealing with the x-axis. The length of this side would be x. The length of that side is y. And your diagonal we refer to as r. The reason we refer to it as r is if we look at the circle here, from the origin to that is the what? Radius. So that's why we call it r. We're going to deal more with that in a little bit. So then over here in quadrant 2, if we were to draw our triangle, Again, our theta is always right there in the corner next to the origin and the x-axis. This time the bottom side is what though? Negative x. Up and down would still be y, but it would be positive because you're going up into the second quadrant. Our diagonal is still r. Your r will always be positive. So now if we're down here in quadrant 3, your theta, again, up there with the x-axis, always the x-axis. This side of the triangle, still negative x. This time going down the side would be negative y. And again, our r still positive. And then over here in our fourth quadrant, completing our little bow tie, we got our theta over there in the corner. So this time we have a positive x, a negative y, and again, still a positive r. So another thing for us to keep in mind, your x-axis on this side, so from your origin out here, that represents 0 degrees. This one here would represent 90, so every angle between 0 and 90 is right there in that first quadrant. This one over here is 180 degrees, so between 90 and 180 would be in your second quadrant. Theta. What do you think this one would be? 270. Yep, this one's 270. So again, 180 to 270 is in here. And then just to complete it off, this would be 270 back up to 360. So that one line kind of is 0 and 360 at the same time. It's got a lot of work to do, that one part. So now what happened is, sometimes people get a little confused remembering when is your x negative, when is your y positive, even though you know your quadrants well, sometimes it gets a little confusing. So what they did is they came up with a way, well, somebody realized, depending on which quadrant you're in, there's only certain trig functions that are actually positive there. So if we are in quadrant 1, all of them are positive. Let's take a look at our little chart down here. So that means your sine's positive, cosine's positive, tangent's positive. So anytime you try to get the value of a quadrant 1 angle, sine, cosine, tangent, all of them are going to be positive values. If you're over here in quadrant 2, only your sine value will be positive. So in quadrant 2, sine is positive, cosine and tangent, those are both negative. Keeping in mind the reciprocal functions go with them also. So wherever sine is positive, cosecant is positive because those are reciprocals, they're best friends. So then since cosine is negative, secant would be negative. Since tangent's negative, cotangent would also be negative. So the reciprocals all go together as far as values go. In quadrant 3, your tangent is your positive value. So sine would be negative, cosine would be negative, your tangent is positive. And then in quadrant 4, your cosine is the positive one. So sine's negative, cosine's positive, tangent is negative. So then what happens is you can just sit there and figure out what the value is and then remember, okay, I'm in quadrant 2, so I just got to make my cosine negative. And then quadrant 3, okay, I got my sine value, I just need to remember to make it negative. So that makes it a little bit easier. You're going to see me draw a lot on my papers this symbol. This is me just kind of shortening it, all sine, tangent, cosine, to kind of help me remember which one's positive when. There's a lot of different acronyms you can use to remember the ASTC chart. Some people call it the ASTC chart. Yeah.
Do you have the acronyms?
Oh, I have one. I have lots of them. So one that people like to use is all students take calculus. I've never been a fan of that because not everybody takes calculus. Another one people use is all students text constantly, which is very true. Very true. My personal favorite, which is the one that my teacher taught me, and I will never forget it ever, all schools torture children. So whichever one you want to go with, you go right ahead and use that one. You will hear me say constantly, all schools torture children. That's what I am referring to when I say it. So you got to remember your little chart. So let's take a look at the bottom. So they asked us, is the sine of 130 positive or negative? So what you should be thinking to yourself, first of all, is what quadrant would a 130 degree angle fall in? Remember, 0 to 90 is here, then to 180 is here, so 130 is going to fall in between 90 and 180. So we're in quadrant 2. So is sine positive or negative in quadrant 2? Positive. So our sine value of 130 will also be positive. All right, question 2. We're picking which quadrant are we in. So our tangent is less than 0. So if we're less than 0, are we positive or negative? No. Less than 0, we're going to be negative. So what quadrants is tangent negative in? Quadrant 2 and quadrant 4. Yeah, because the quadrants are Roman numerals. You have to use them. You can't tell me just regular 1, 2, 3, 4. All right, so sine here is less than 0, so my sine is negative. Cosine is also less than 0, so cosine is negative. So where is both sine and cosine negative? Quadrant 3. And so then our last one, we got tangent is less than 0, so tangent's negative. Sine is greater than 0, so sine is positive. What quadrant are we in? No. 2. Remember, quadrant 1, everything is positive. That's a plus sign.